Hello everyone, this is Hybrid Accounts, and today we're just going to take a look at the least cost method of the transportation problems. Transportation problem least cost method. Now, actually this is the better method compared to the northwest corner method. This one is the better method, and we say, how do we go about it? Just as the term states itself, of the least cost, the cheapest route is the focus for allocation. It is the better method compared to the northwest corner method as it considers cost for allocation. So it really considers costs. The following are the steps to use so as to reach the solution. So steps. The first step, select the cell with the minimum transportation cost and make an allocation. So just like that, you just go for the cell with the minimum allocation and actually you make an allocation. And then you eliminate the exhausted row or column. So if there's any row or column that has been exhausted, you just eliminate it. Now, what if there are more than one cell? There are two or more cells with the minimum transportation cost here. If there are two or more cells having the least cost, then any of those cells for which the maximum allocation can be made should be selected. So in case one destination, one cell actually allows allocation of 400, but the other allocation of 500, then you would have to allocate in that allowing for 500. And in case actually the maximum allocation is the same, you can choose any of the cells. In case one cell has 400 allocation, 400 units, and the other 400 units, then you can choose any. And so here, repeat steps 1 to 3 until all allocations are made. So just like that, repeat any until allocations are made. And after that, obtain the initial basic feasible solution. So let's just go and take a look at an example directly. Here we are, example 4. This is just, I advise you actually to take a look at the northwest corner method again in the previous, because we are doing the same example. So it's nice for you if you compare the results. Example 4, the cost of transportation per unit from 3 sources and 4 destinations are given in the table below, as the transportation costs are on a per unit basis and $1,000. So these are the transportation costs: 42373, 3728, and actually here we have 10, 4, 10, 4, 3, and 1, just like this. So we are required to obtain the initial basic feasible solution using the least cost methods. Actually, it's solution, not solutions, it's solution. So this is what we are going to do right now. So let's go to the solution. So first of all, you should check whether the problem is balanced or not. In our case here, the problem is balanced. Why? Because total supply equals to total demand. Supply is down here, 450 plus 250 plus 350, you obtain 1050. And then as for demand, 250 plus 300 plus 200 plus 300, you also obtain 1050. So obtaining this shows that the problem is balanced, and then you can proceed further. So now let's go. I've just recopied the question here. So this was our question, and the problem is balanced. Now, how do we make an allocation? So you just find the least cost among these ones: 4231, 3723, and here 10431. So 1 is the least cost. So if 1 the least cost, we have to make an allocation here. So you ask yourself, down here, there is a demand of 300. And actually, if you go to the right, there is a supply of 350. So the demand is 300, but there is 350. So 300 would be supplied, because actually the demand can be satisfied. In case 300 was greater than 350, maybe this was 250, then you would have to supply the lower, that is 250. So we just go and assign as this. You supply 300 here, and then the demand actually is exhausted, and then the supply of 350 units actually remained with 50 units. And so, as we said, eliminate the exhausted row or column, Now, destination 4, which is the column, has been exhausted, and so it is eliminated. So we remain with only 1, 2, and 3 here. It's shown down here, 1, 2, and 3. And so we have 1, 2, and 3, and then so 1, 2, and 3 again. After that, you determine the least cost again. The least cost that there is 4, 2, 7, 2, 7, 3, 10, 4, and 3. The least cost is 2, but 2 is here. 2 is here, but it is also here. So you'd have to go for the one actually giving the maximum allocation. So if you allocate here, demand is 300, but there was 450. So we could have supplied 300. But if you come to these two here, demand is 200 and there is 250. So you could have supplied just 200. And this could have been the problem. And that's why we supply here 300 because it is higher. So by supplying 300, this actually destination is exhausted with the demand. And this which supplied 150 and it had 450 remains with 150 units, just like this. And again, destination 2 has been exhausted and we eliminate it. So we remain with only destination 1 and destination 3. So that's why I said here, delete column 2, which is here. So again, here you are. You have removed column 2, you just have column 1 and column 3. And again, you determine the least cost. Now we had 4, 7, 2, 3, 10, and 3. So the least cost is 2. 2 is the least cost. And then you ask yourself, it requires 200 units, but there are 250. So it is provided as 200. It is exhausted, and the one that supplied to 200 remains with 50 units. And again, destination 3 is exhausted. So you remain with just one destination, that is destination 1. Now, whenever you remain with destination 1, a single destination or a single source, there is no need to make complications. You just assign, because since there is a destination of 250 and just one destination, that means it would have to be supplied from all sources. So source 1 had 150, it would supply all 150 here. Source 2 had actually 50, it would supply 50 here. And source 3 also had 50, it would supply 50. This would give a total of 250. 150 plus 50 plus 50 would have a total of 250 and they would be done. So down here is just all allocations in one table. Actually, in an exam, you do not need to draw table by table after table, table after table. You can just do it all in a single table. So I just made a summary here. From source 1 to destination 1, it's 150. And this one, from source 2 to destination 1, it's 50. It's down here. From source 3 to destination 1, it's 50. It's down here again. And then you go on for other allocations. For example, here, from source 2 to destination 3, it's 200. Source 2 destination 3 is 200. Source 2 destination 3, 200, and the rest. So this is just a summary. So after having this summary, you can just go on and compute the cost, just like this. So as you see here, source 1 destination 1, 150 units times 4, which is 600. 150 units times 4. Source 1 destination 4, 150 times 4 here. 150 times 4, and then 300 times 2, and then 50 times 3, 50 times 10, and here 200 times 2, and lastly 300 times 1. Remember that these ones are the units transferred, and this one is the cost per unit. So cost per unit times units, you obtain total cost. And so you'd have the table like this. And after summing your numbers, you would end up with 2,550. If you take a look at the northwest corner method, we obtained a much higher cost, meaning that if you use the least cost method, actually the cost decreases. It reaches the optimal solution more quickly, although it may not be optimal itself. Now everything is done. So just go with step 3. Because this is not an optimal solution, we usually use the stepping stone method or any other method to reach the optimal solution. So it could be asked to check for degenerates. For example, if there is degenerates, actually you cannot reach the optimal solution and you first have to eliminate it. Now, for our case here, we made 6 allocations. The first one, the second, the third, the fourth, the fifth, and the fifth here. So n, which is the number of allocations, equals to 6. And what about m and n? M and n are just numbers of rows and columns. We had 3 rows, that is 1, 2, and 3. And we had 4 columns, 1, 2, 3, and 4. So we can just count them here. Number of rows equals to 3 and number of columns equals to 4. Now you just have to go and check whether this is equal. If n equals to n plus n minus 1, that means there's no degenerates and everything is fine. So you can start determining the optimal solution. So here, n equals to 6, m with 3 plus 4 minus 1 equals to 6. So right-hand side and left-hand side are equal. And so, in case we had to determine the optimal solution, for our case, we are not required. We are just told to use the least cost method. We would go straight away for the optimal solution method. In our case, the stepping stone method. So you can use the stepping stone method to reach the optimal solution. But for our case, we are not asked that. For our case, we just have to end up here. So this is how we deal with the least cost method. Thank you very much, and until next time.